your screen.
All right, folks. Good morning, everyone, or good afternoon, depending where you're at. Share my screen here real quick. Maybe. Can everybody see the PowerPoint? Let me try that again.
You had it.
Oh, I did. Sorry, minor technical glitch. Well, like I said, good morning, good afternoon. My name is Greg Allen. I am an application engineer. I actually am in the power roof ventilator business unit of GreenHeck. My job is to answer questions, to look at applications, and to keep an eye on the very green world of items. That's actually my specific duties. So today, as Tracy had said, we're gonna take an overview of fan energy index, or FEI, and then we're gonna go into how that impacts selection, and we kind of spend a little time around making some selections and some points that I look for when I'm looking at different fans. So without further ado, we will go from there. So of course, there's a agenda, what, why, how, the whole works. So let's go right into this. FEI stands for Fan Energy Index, right? So what is an FEI? Well, FEI was first developed by AMCA, the Air Movement Control Association International. FEIs are also defined within the Department of Energy. And what is it? Well, so an FEI, it is a simple ratio of fan efficiency to a baseline. So there's two methods here we can look at. I can look at the fan you are selecting compared to a baseline fan and say, okay, this is where you're at. More common route to take is the wired air method or shaft to air method. And this is literally looking at how much power am I consuming versus what am I getting out of the fan. Now, the last line here on the slide is actually a key statement. We are not just looking at peak efficiency for one fan, because even though a fan could have a great peak efficiency, where you're using it or at what performance point you are using that fan, it could shift drastically how efficient that fan actually is. So one of the biggest benefits to an FEI is the fact that it is calculated at a given airflow and pressure point, at that performance point. So with all that said, this is an excellent single value way to compare fans in an application, taking into account variables such as fan size, your system's pressure, proper applications, if a VFD is being used, direct drive versus belt drive. All things are actually pulled into this wired air calculation. So let's give you, that was a very broad explanation. What is an FEI, right? And it is a single value that is going to help you compare fan to fan. So let's look at a graph. This is right from AMCA. Ooh, come on, you can do it. All right. And on this graph, typical chart, we are looking at static pressure on the left, airflow across the bottom. This is your fan curve, right? And on top of this fan curve, you see your different RPM curves as you go along, and you have your peak efficiency line. What we're looking at is you can see if I pick a point anywhere in there, the FEIs, and I'll try to use my mouse a little bit here, the FEIs actually change by where you're operating that fan on its fan curve. So 3 different fans that all can do the same performance will have different FEIs, and you'll be operating at a different point in their capabilities. this is important because although 3 fans can all do the same performance, what's the best fan for my application? And FEIs are an excellent way to put your finger on that. Hey, this is a good selection, or maybe this is not a good selection as far as fans go. So why do I use an FEI, right? So the first reason to use FEIs in your fan selection process is it's a just an easy way to compare one-to-one. Right now, when I look at fans and I look at different fans I can use for performance, I'm usually using items like, hey, can it meet my performance? Kind of an important one. I'm looking at the cost to operate, which actually coincides with FEI numbers, so not surprisingly. So I'm looking at the cost to operate, the cost of the fan, the performance of the fan. Of course, I'm looking at horsepowers and brake horsepower. Where am I operating? What kind of wiring? What kind of motor protection do I need? So I'm looking at all those things, and I'm trying to rank these fans in order, and trying to grab the best one, the right one. Since FEIs have been implemented, I can simply look down a column and have a quick reference on, is this a good fan and a good selection for my application? And of course, FEI is not going to take into account your environment, as far as like if you're dealing with a smoke control type application, or if you're dealing with, an explosion requirement for an application, you have to select the correct fans for those applications. And I'm kind of not going there. You do need to select the right fan for the application you have. But when you compare fans, the FEI is a great way to just rank and order them. Also, due to that wired nature, the FEI will encourage or push you towards certain good aspects, like direct drive fans are going to be more efficient. Variable speed, if I can actually operate at the right point versus over operation and moving more than I need. FEIs are also going to discourage just selecting a fan that is maybe not good. In general, I can say that large fans are going to have a better FEI. If you have a large fan that moves slowly, you're going to have a better, more efficient selection. You're also going to have better sound characteristics with that larger fan. Now, if I go down 2 or 3 sizes, can I get that fan to do the same operation? Yes, I probably can. But that fan is spinning at its top end. The sound is going to be much higher. And where it's operating in its capability, the efficiency is not going to be as great. So FEIs are just naturally going to help encourage you to good selections. Also, specs are an important thing, folks. As we're creating them, as we're trying to meet them, you will find as we move into the future together that FEI minimums will be starting to be called out, and in some areas already is. And that'll be like, hey, a minimum FEI for this application is going to be a 1.2, which is great. You or they are communicating what your minimum requirement is. So that is going to, again, encourage you into selecting certain types, certain sizes of fans that can operate at that minimum level. And of course, that last little word there, rebates. There are programs today, and there'll probably be more programs in the future, where you actually get encouraged monetarily to select fans that are good stewards of electricity. So that's a great spot to kind of jump off here into what are the benefits of fan energy index and selecting fans using those. So benefit number 1, energy savings, right? And that's really got to be at the top of our list here. fan energy index was really implemented and created to allow us to be better stewards of our electricity, our power. And if we can use more efficient fans, that affects everything down the line to the building owner who's having to pay the monthly bill, to their interaction with the power grid, kind of the whole works. FEIs are encouraging that energy savings and proper usage. Did I hear a question there? Or? All right. I will keep on. By the way, going through this short part of the selection, and we are encouraging questions. Please do. All right. So that FEI, and I kind of hit this earlier, it encourages a proper fan selection. It truly is, discouraging you or pushing you away from fans that maybe can do that performance, but aren't intended for it or not as efficient in that application at that performance point. Another benefit is that from an engineer's seat, you can sit there, you can look at several selections, and without too much investigation, you have an easy value just to do a straight comparison. And of course, meet specs, take advantage of rebate programs. That is definitely a benefit. And there are, speaking of rebate programs, I'm not sure of your specific areas, but I have heard of parts of Michigan, Minnesota, Indiana, South Carolina, Colorado, Oregon. I mean, there are organizations that will have rebate programs that define, hey, if it's this type of fan, say it's an inline fan, and you're operating at 1.2 FEI or better, you are now capable of benefiting from this rebate program. And typically there's up to a certain point, for each fan. So you kind of add that rebate up to typically a maximum. But this is definitely a benefit and encouragement for us to make good selections and efficient selections. So FEI is in use. Catalog data. So we had mentioned right up in the front part of this presentation that this is an Amca created program that's being adopted and used through the Department of Energy, etc. Amca is a very large third-party testing, certification, codes writing entity, right? And you have the ability to be tested, certified, to have your sound data or your performance data. And there's that really cool Amca sticker right on the side of fans that meet that and are part of that program. There's a real value to having that third party look, because that down to the performance you're looking for, you're comparing apples to apples across manufacturers, as long as they all are Amca certified. Now, there's also Amca certification for FEIs. So again, this is not a number that I'm just throwing out there, as a manufacturer. This is actually a number that's reviewed, tested, and in the catalog of your products to be properly used by the consuming market. Kind of mentioned this earlier. The larger, slower fan, many times you can get to a point where it's too large and running too slow, and your FEIs will again drop. But it does encourage, you'll hit those higher numbers above 1.0 typically when you select a larger fan. When they have minimum FEIs required, I'm just kind of throwing this out here just to make sure everybody's aware. Many times in the rebate programs or in the specs I've read, they're actually going to have two scales. They're going to have a scale for minimum FEI without a VFD. And then if it's an application that requires VFDs, there's actually a second scale many times. And this is because in the FEI, the way you calculate it, and there's an entire long calculation, testing the whole works, where if you apply a VFD, you actually take a slight hit to your FEI numbers, but then you gain that back by being efficient operating in a zone, okay? But because of that hit, many times you will see two different scales, something to watch out for. So, where if you're without a VFD, the statement might be you must meet a minimum FEI of 1.2. And then it says applications where VFDs are applied, minimum is 1.0 or 0.98. So that look for those statements and in the sliding, the different scales when they're used. Also, when we're talking about fan energy index, today the way it's applied and used is for 1 horsepower and greater applications. So when you're down in that fractional zones, there's no typical requirements or even calculations for that fractional values. Now, I know personally we're conducting testing even down into the fractional motors so that we can calculate a proper FEI. But when you look at codes and requirements and encouragements, that all starts at that 1 horsepower and up zone. So I kind of wanted to throw that out there. So right back into fan selection, this is where the rubber meets the road. We're going to start applying that FEI knowledge, the fan energy index knowledge. So we saw this graph earlier. This is a great fan chart or fan curve, excuse me, of a fan that has a very large, good number FEIs throughout that middle zone. Let's compare that to a lesser efficient fan for that application. And you can see where that FEI of 1.0 or better, the dark red area, is much smaller. So when you look at where you're operating within that fan curve, you can see, okay, I'm in that 1.0 range, or maybe I'm out. I'm down in the 0.8 range. A less efficient fan or an improper selection or not as desirable of a selection many times will actually push you off into those lower values. So wanted to throw up that sticker for AMCA, Air Movement Control Association. Here you can see what it would look like for a product that is sound, air, and FEI certified by AMCA. I think if it's just sound and air, I believe it's a blue and yellow sticker. Also pretty colors, but here we can have the green and yellow. So kind of in conclusion for the FEI, and I kept this discussion and presentation fairly short and high level. I didn't feel anybody here wanted to know how to run the calculations for a wire to air fan. I put most of you to sleep quite quickly. Important stuff, but probably not what this presentation was designed for. But the FEI is a metric that really helps us compare fan to fan, right? Is this a good fan for the selection, or is this not a good selection for this application? And it really concentrates on that wire to air, shaft to air theory, where I'm looking at power in versus power out. And this is going to help me grab the right fans at a specific performance. And I'll hit that one more time, that the FEIs, as you can see on those fan curves, changes depending on what performance point you select that fan. Now, much of this information that I've just presented, you can find right at the AMCA International's website. So make sure no one's thinking I'm making stuff up here. You're welcome to check them out. Any questions that we can kind of start off with on FEIs? Well, I suppose we're going to do questions at the end. So my next slide here, I just wanted to throw a quick blurb in. This is just information added, something that I've done, that GreenHeck has done a little differently for many of our business units. And this is first, FEI Data. One of our main jobs is to implement and get this data on our catalogs so that you can use them like we just talked about, right? And this is actually to extend, it's really quite easy to get the FEI values for, 1 horsepower and up, AC induction motors. They have really cool tables, easy calculations, and those values, like in our selection software, the CAPs, computer aided product selection, and ECAPs actually reference those Amca tables today and show you the values. Now, a little cat out of the bag, over the next couple of months, with the update in CAPs, you're actually going to see those tested values for what we would call very green fans as well. If you look today, very green will show up as a dash because it's not an AC motor. We had to do a bunch of testing to get those values put in. So our next version of CAPs, those values will start showing up, and you're going to be able to compare a 3-phase AC motor, head to head with a very green motor. And when I say very green, that is a GreenHeck term. I am really talking about fans that are ordered in the variable speed, high efficient nature, like EC motors, synchronous reluctance motors, motors with drives. Those are the kind of things that would show up as a very green selection within GreenHeck software. And of course, I just wanted to throw out a little bit more information at you. Questions I've been getting lately are about short circuit current ratings. That's that rating where an amp over that rating is going to cause catastrophic failure. Typical values are like 5K. I've seen some specs require 50K or 65K. This is a value that you can call a manufacturer up and request, what value of SCCR does this equipment have? Many times it's labeled right on the equipment, depending what it is. This is something we've added to many of our submittals. So, depending on how you selected the fan, what type of disconnect you chose, this actually can show up for you right on the GreenHeck submittals. And information that's brought along with that is minimum current ampacity and maximum overcurrent protection. Now, many times when you're showing these values, these values are to help you size wire or size your breakers. And that's mostly derived off of the NEMA tables for common FLAs for horsepower at a voltage. So the good news here on the miscellaneous notes, and that is that much of this information many times is being shown right on the fan submittals. So excellent stuff there. What I'm going to do here, unless Tracy wants me to pause, is go into fan selections.
Go ahead with that.
Perfect. All right. First thing I'm going to do is I'm going to go to the most awesome website in the world. Everybody should see it, and that's greenheck.com. Yes, I am biased. In here, I'm going to type in ECAPs, right? And ECAPs is our engineering caps program. You can log into this program without, if I can click it. Come on. Let's just go this way, since my browser was being funny. So you can get into this without an account. You can see I'm logged in as guest. I do recommend that you click on this and you create an account. I don't believe there's any cost associated with it. And there's some real benefits of having an account as well. But again, this is basically our catalog online, right? You can go to the paper catalogs. You can get those online as well, and you can look at pressure versus volume and select fans and see some curves. But this is another version of our AMCA certified data. And in here, ECAPs, engineering caps, is an entire program, has some really cool stuff here. But let's see how it affects selection and even wrap in FEIs to our discussion. So I'm going to say, let's look at a fan. And for conversation's sake, let's say I'm looking for a roof exhaust fan. Now you can see here, I've broken out fans into groups, right? Wall mounted, ceiling cabinet, vane axial. The nice part about ECAPs is that I'm not saying an exact fan. I'm saying, show me all roof exhaust fans so I can compare them. If you look at that versus anybody who is a caps user here, in caps, you're usually going, I'm looking for a G fan, or I'm looking for a cube fan. You're starting with a known model. Here, it's much more open. So we're going to go into roof exhaust. Let that gunculate for a moment. And we have our basic inputs, any certifications or requirements, advanced inputs, and corrections that we should be aware of. For today, let's put in 10,000 CFM is our need. And we're going to say 0.375 inches of water column. And then our elevation, 980 feet. So this is really the minimum information needed to look through the catalog and see what fans will do what we're asking. Now from here, you can see across the top when I am done searching. One moment, please. You can also define here other items such as airstream, housing styles, discharge. You can further refine what's shown below by filling in the information above. I went with the minimum. Let's click on these other ones quick and just look at what they're offering us. Is this fan need to be high wind rated, seismic rated? Is it a restaurant exhaust, a UL 762 rated fan? Is this an emergency smoke control fan? Does this fan need to be spark resistant? So again, as you put more information in, it reduces the output to only fans that can meet that. And there are advanced inputs like, do I want to take into account drive losses? Do I want to specify that this is I want it to be VFD controlled, drive types, are we going to allow performance baffles? Performance baffles change the characteristics of a fan and where it performs on the curve and what its curve looks like for that. And the last is, hey, I've got a damper right at the fan, say it's in the, right against the fan. So I want to account for any pressure losses, pressure drops across that right here. So we're not going to have any of these advanced inputs yet, but let's go down into here. And we do a kind of a quick ranking across here. And we're looking at, sound, we're looking at cost, horsepower, and we kind of do a general ranking. But you can see that 176 fans showed up with just the performance point I'm looking for. And these are all different types of rooftop exhausters, from a prop type exhauster to a centrifugal wheel upblast or downblast. Kind of want to pull your eyes to the right here, and that is the FEI column. And as you can see here, we start having values. If the fan that's being shown is less than 1 horsepower, you're going to get a dash. There's no FEI requirement yet for those. If you can see here today, like I have a G300, which is a Downblast 300 series, very green. Today, it shows up as a dash. In very short order, that will actually show up as an FEI as well. And to give you an idea, this FEI for a EC motor, for the very green selections, you will find many times are about 0.1 or better versus an AC motor. So just kind of keep that in mind. What VariGrain is doing for you is you pick up about, about 0.1 better. All right. So with that said, let's look at a selection and see what's good and see what's not a good selection. So let's do a downblast today. And I'm going to do is I'm going to select a belt-driven 330. We'll pick a size 300. Let's pick also a downblast size 260. So roughly a 26-inch wheel versus a 30-inch wheel versus a 33-inch wheel. So as I put the check mark on those, I can come to the bottom here and say, let's compare them. So let's look at size. Let's look at weight. Let's look at it, load. So here we are, nice little picture. We can see right across the top, the different sizes, general purpose clean air applications for a downblast fan. Our weights are within, say, 10 pounds, pretty good. All of them can hit our performance. Inlet dBA, 65 for the largest fan, 72 for the smaller fan that's spinning faster. Okay, that makes sense. These are budgetary prices, just to kind of give you an idea. And we can see the costs in fans, and just more further descriptions. From here, across the top, I have fan curves. So here we're looking at the 260, the 300, the 330, and we can see that they all cross at that same 10,000 CFM point. So yes, all three of these fans will do the same performance. Now you can see that since they do the same performance, let's look at sound quick. And this really relates just to the data I showed you earlier. The yellow line for the GB330, it's a smaller fan spinning faster. It's going to have more noise, right? Versus the larger fan spinning lower. And we're going from, what was it, 65 to 72, I believe. Yeah, decibels, 65 to 72. 5 decibel change is noticeable. 3 decibel change, you really can't tell the difference, but at 5 you can. At 10, it literally sounds twice as loud. So that's where I'm looking at the difference here. I am 7 decibel different. Again, depends on the application. Maybe sound is not important. Maybe you're working for a theater project. The sound is extremely important. So good fan selection means looking at not just performance, but sound, size, cost, efficiency, all these different key terms. So I'm going to close those and clear my selection. Let's look at this right here specifically, and I'm going to click right on the GB330 point. So this is the smallest fan that we were looking at. And of course, the first thing I want to look at is, will the fan perform? Will it move the air I need it to move within the system I've defined? Here's your fan curve. Yes, we'll hit 10,000 CFM at 3/8 of an inch of static pressure. We are not selecting in the do not operate zone, where you're likely to hit surge and can have massive losses in performance. But one thing I want to point out here is the fan curve operating. I'm looking at operating conditions right now. Did you know you can click on that and select alternate curves to look at? And this is a really important point when selecting fans. I always recommend we look at the MinMax curve, because this is going to show us, are we selecting this fan at its maximum capability or its minimum capability, or somewhere in between? How much ability do I have to overcome minor static pressure changes within the system? Say that the ducting was taken a couple extra elbows than design had it. Well, your static pressure will start to climb. In this scenario, you can see that my top line, my max performance curve, and my operating point are really close. This on a fan curve look only would not probably be the best selection. It may be the most cost-effective selection, but this gives me very little room to wiggle and actually speed up the fan and overcome a minor system effect or a little extra static pressure. You know, I'm also operating on the bottom half of the curve where a minor change in static pressure is going to create a very large change in performance. All right, so that's again looking at the smallest one. While we're here, let's just scroll down quick. Some important information. You can download your Revit files, your drawings in different formats. When you look at Revit, you can do different LODs or level of designs, LOD 200 or 300. So all this information, when you find the fan you want, this is great to have. You can pull it in, you can create fan schedules, excellent stuff. Now that had a FEI, that 260 had an FEI of 0.77. This is a hard one, but rule of thumb, when you start getting down in the 0.8s and lower, you might want to reevaluate the fan you're looking at for that application. So let's get away from that one and let's go up to that GB330. This had an FEI of 1.21. And let's see what that looks like. Again, all the same information. And of course, me being me, I'm going to go right to the MinMax curve. And this top purple line is the fan's max capability. And the red line is our operating RPM. So where it intersects with the system resistance curve, this is our operating point. Here, I can see that, well, I'm about halfway between min and max. You know, that is a very nice place to be. I have plenty of room for turn down. I've also got that room to turn up. Now this has got the highest FEI value. We're selecting in here. If we look at the 300, which was our other comparable, we would be up in this range right here, probably at 80% of the fan's capability versus 50% of the fan's capability. And I always do a little bit of simple math. You know, here I'll take 487 fan RPM divided by 701 and give myself a percentage. You know, am I at 50%, 60%, 80%? You know, and of course, me being me, I try not to select fans that are higher than that 85% mark, but that's because I'm a little conservative. And again, all the other drawings that we were looking at. So I'm kind of wrap this all together. You can see where FEI is that single value digit that, or single value that helps me compare across different fans. And in ECAPs, I'm even comparing a centrifugal wheel versus a prop, you know, looking at the most efficient. And of course, I can start bringing in secondary criteria then to make a good selection. So I'm looking for a good FEI. I'm looking for the correct sound values or range of sound values for my application. You know, I'm also looking at, you know, how it mounts, what kind of curb I need. You know, what am I exhausting? Is it clean air? If I'm doing UL 762 or restaurant exhaust, I'm going to get that upblast fan. The props won't even be shown anymore because they can't meet that rating. You know, so I'm comparing across all of these using this software platform. And last little point here is if FEIs, I'm trying to meet a requirement or a rebate, whatever it may be, I can click on this value right here and it'll reorder the entire 176 fan list into highest to lowest or lowest to highest. So if this is my overriding criteria, I can simply get to the number one highest, or I can look for, say 1.2 is our requirement. I can know that the fan I need to select is somewhere, here and above. And of course that works as well for sound. Say sound was your overriding criteria. Don't usually pick the loudest fan possible, but or brake horsepower, etc. So you can click on the column and actually reorder the information.
So real quick, we have a question here that's actually about the ECAPs. Is there a specific metric or several metrics that CAPs or ECAPs defaults to ranking the available fans by? So what metrics?
If I don't click across the top here and do my own rank and file, there is a standard kind of a green heck, excuse me. You can see the ranking here, 1, 2, 3, 4. This is our own made up metrics in a way. And all we're doing is we're bringing the sound characteristics, the power, efficiency, and cost. We're looking at that combination, and this is our own algorithm to try to lead customers into good selections.
Okay. And I think it's based on sound, brake horsepower,
sound, brake horsepower, cost, and yeah, I believe it's cost.
Yeah. Okay. Next, what's the relationship between brake horsepower and FEI? And then what's the difference between FEI and fan efficiency?
Okay, well, let's take that, I guess, one at a time. Brake horsepower is a part of FEI because we're doing the wired air app calculation, but it's not a 1-for-1. If you're going to use a 5 horsepower motor and your brake horsepower is down in the 0.3 range, that's going to actually give you a very poor FEI. But if you're at a 1 horsepower and your brake horsepower is 0.99, that will also work against you as well. So it's involved in the equation, but I wouldn't look at it as the FEIs grow, your brake horsepowers are ordered as well, because it won't actually work quite that way. And then the second part of the question was, how does FEI compare to fan efficiency? Now, fan efficiency can be looked at in a couple of different ways. We could be looking at total efficiency or static efficiency. And these really, the total and static efficiencies, kind of roll into the previous program of FEG, or fan efficiency grade, excuse me, fan efficiency grade, took those values. And they're excellent when you look at a fan that's performing at 100% full load. They're very telltale on those values. Where they fail, though, or I shouldn't say fail, where they're not as good, is when you're looking at fans operating at part load, part load, or we're looking at different construction of fans. So a axial fan or a sidewall fan, comparing it to a centrifugal inline, the FEG values don't compare those two products very well. Where if you look at an FEI, because we're just looking at power in versus power out, it's not taking, it is actually taking into account actual efficiencies and where you're operating at the curve. And then like we saw with those graphs of the FEI in the beginning part of the slideshow, that different operating point will affect where your FEI is calculated.
Okay, great. Fan energy index gives us an unbiased comparison of fan choices. Does this mean that the higher FEI, the more expensive the fan is? In other words, does the fan cost automatically track fan FEI?
The overall answer is no. If I am comparing, say I'm in a warehouse where it really doesn't matter what kind of fan I need, I just need a fan that's efficient and a fan that has the performance. FEI would be a great way to look at, say, an axial versus a rooftop exhaust. And you're probably going to hit two different price points. Well, in this application, let's just compare here, two that are close. Okay. Oh, I picked one that doesn't have an FEI value. So in this scenario, the RBU, which is a rooftop hooded unit, has a FEI 1.26. That's good. And the Downblast power ventilator is a 1.21. So both selections, good FEI. Let's just compare and look at the cost here real quick and see if that holds true. And it may, in many applications, be that the more expensive fan has got the higher FEI. That may happen. In this scenario, the more expensive fan has the higher FEI. So yes, sometimes that will work out that way, but I know I'm not looking at FEIs and changing the prices of the fans as well. I'm sure I can find one application or one scenario where the FEIs are backwards. And that could be due to the cost of the fan itself or the construction of the fan itself, especially if I start comparing like, say a blower style, fan that, yeah, it can hit the same performance as a downblast power ventilator. But due to construction, their FEIs might be really close, but the cost differences, I mean, one fan's got a lot more meat to it, a much larger fan. So long story, not so short. It's not one for one. The higher FEI, the higher the cost. But you will find that, like when we did our example, those three different sizes of the same fan, well, the biggest fan, the most expensive fan, was the one that had the higher FEI, but that was due to size and operating point.
So, and this actually goes with the question that just came in. Something we've heard around here at the Holden office is, should engineers start scheduling this now? When should they start scheduling it? Is it going to be, required?
So that's a great question. And I wish I had a really awesome answer for you. This is one of those scenarios where as requirements start dictating minimum FEIs, like the Department of Energy has pushed its way down and it's been adopted into our local areas. Well, yeah, then you definitely will toe the line and make your selections and put that right on the schedule. Until then, in my mind, and I have to kind of say this is a ROG or a rule of Greg. I use FEIs to make a good selection when I'm looking within fans. Certain areas, and I've seen like in Oregon, where they actually have a lot of your fan schedules and specs actually state minimum FEI on them. Here in Wisconsin, I haven't seen that yet. And honestly, most of the engineers around me haven't even played with FEIs yet. It's not a requirement. They're not going to do anything with it. But you should be aware of what's coming for requirements and the benefit that this value can hold for you. So that's my way of skirting around a better answer.
Yeah. So the next question is, ASHRAE 90.1 requires fans to have a minimum FEI of 1. This means that fans of a lower than 1 FEI will not be acceptable.
Which Amca release is that?
That's ASHRAE 90.1.
Or ASHRAE, excuse me. So it depends on your area and if you've adopted that release. A lot of the areas I'm working with are still in the 13 to 15 range. Forgive me for the dates. I'm not aware of them.
Yep.
But here, I think that shows up and I'm trying to remember. It was a 17 or 19, something like that.
So we have a couple more questions from registration. The difference between VG motors and VFD motors and when to use.
Okay.
Just
well,
a simple.
Yeah, VG is a green heck term, and can represent an AC motor with a VFD. Typically, since 2009, VG has been more closely associated with EC motors or ECMs. When to go with what over what? Well, the right fan at the right cost, that's important. Another one is what power do you have available to you? If you're looking at a half horsepower motor, and you have single phase available, that EC motor is going to be like heads and tails above any other single phase motor. But now, do I want to apply a VFD? And now I'm getting a special VFD that can take single phase and break it out to three phase and a different motor. That cost can climb greatly and kind of price itself out. When I'm in the 1 horsepower and up market, then I'm looking at Very motors versus VFDs. For me, it's the spec, how the building's being made. It's the cost of the fan to help me make the right decision. Of course, I'm very pro Very Green, but every application's got its best choice. And just kind of a side note, all Very Green motors have a version of a drive built into them. So all your motor protections, your speed control, your soft start, all those benefits you get from a traditional VFD are incorporated in EC motors, in Very Green motors as well. So you're kind of getting a packaged unit that doesn't need to be programmed by the outside world.
Agreed. So I think we got about one more question here. Best strategies for selecting variable speed fans with large variation in minimum and maximum controlled speeds.
Excellent question. So back to that min-max curve. I'm going to start this answer off by saying that the folks over at Holden are going to be your best bet to make sure you get the best fan that can operate at multiple points. Sometimes a human interaction is an excellent thing, and they're good at what they do. From there, back to that min-max fan curve that I work with a lot. I'm looking at those different operating points. I'll look at the 60 hertz operation, max speed. And then, for me personally, I'm a bit conservative. I use 15 hertz as my minimum. I'll try to select the fan size that squeezes in my top end and still brings down my bottom end. Every now and again, you need to dip into that 13 hertz. That's all right too. But today, that's the best solution is to actually look at, put in your max criteria, your highest CFM, and then look at that fan and say, can it go down that far? Sometimes the answer is a single fan can't do it. I have come across those applications. Sometimes you actually need to run 2 fans, but many times you can get there with 1 fan.
Okay.
And a note for the future, it's one of the projects I'm working at GreenHeck is to be able to take more than 1 operating point and show them on the fan curve. So it sounds like I'm on the right path for my current projects.
Yeah, that is something that we see very often. Using that min-max fan curve is big, and you can actually get that in ECAPs. And when we send you a submittal, we should be including the min-max curves in the submittal also.